Today we're going to dive into some really fascinating research from Anthropic that tackles what is basically a holy grail of AI, building an AI system that can autonomously create entire complex applications all by itself. So let's see how they pulled it off.
I mean, seriously, think about that. What if you could just type one sentence like, hey, build me a 2D retro game maker, and then walk away, and a few hours later you come back to a fully working, totally playable app. Now that's been the dream of AI agents for a while, but, well, if you've ever tried it, you know the reality can be a whole lot more frustrating.
The truth is, when you give them these big, complicated, multi-step projects, even the most powerful solo AI agent tends to, well, it loses the plot. It might start off really strong, but as things get more complex, the quality just nosedives, bugs start creeping in, and that original vision, it completely falls apart.
So what is going wrong here? Well, researchers have pinpointed a couple of key reasons why they fail. And you know what? They sound surprisingly human. Let's break them down. First up is something the researchers call context anxiety. Basically, as a project gets longer and the AI has more and more to remember, it kind of gets overwhelmed. It loses focus and just tries to rush to the finish line, often cutting corners. And second, and this is a huge one, is poor self-evaluation. If you ask an AI agent to critique its own work, it's way too confident. It almost always comes back with, yep, looks great, even when the code is a total mess. It's just a terrible judge of its own quality.
So how do you fix a problem like that? Well, Anthropic's solution was pretty brilliant. They didn't try to build one single smarter agent. No, instead, they built a smarter system of agents, a team of rivals, specifically designed to keep each other in check.
And the inspiration for this actually comes from a really powerful concept in AI you might have heard of called Generative Adversarial Networks, or GANs. The core idea is simple, but it's so effective. You have one AI that creates something, and you pit it against another AI that's job is to find all the flaws. This constant back and forth, this adversarial process, forces both AIs to get way smarter, way faster.
Which brings us to this system perfectly. You've got a generator agent. This is the creative one, the one that's actually building the thing. And then you've got an evaluator agent. Think of it as the harsh but fair critic. Its entire job is to inspect the generator's work, find every single bug, and provide brutally honest feedback for the next round.
All right, so let's see how this system actually does in a really tricky, subjective area, website design. I mean, how in the world do you teach an AI to have good taste?
Right, you can't just tell an AI, hey, make it beautiful. It doesn't work like that. So instead, the researchers broke down good design into concrete things it could actually grade. For example, they measured originality by punishing the AI for using generic, cliché AI patterns. They graded design quality by rewarding a coherent, unified look and feel. This gave the evaluator a clear, objective rubric to score the generator's work.
So the team gave the system a creative task: design a website for a fictional art museum. For 9 straight rounds, the generator and the evaluator went back and forth, refining and tweaking the design. And the result was, well, it was pretty good. It was clean, it was polished, very professional. But it was also kind of boring. It looked exactly like what you'd expect an AI to make.
But then, on the 10th try, something incredible happened. Pushed by the evaluator's constant nagging for more originality, the generator had a real, genuine creative breakthrough. It threw out the entire conventional design and came up with something new, a 3D spatial website where you could actually walk through virtual gallery rooms. This wasn't just a small improvement, it was a completely different, way more creative idea. And that is the power of this system. That constant critical feedback forces the AI to break out of its default, boring patterns and explore something truly new. You just never get that from a single-shot prompt.
Okay, that is super impressive for a creative job. But can this team of rivals handle something that's deeply technical? Let's look at the ultimate test: building a complete, full-stack application from just one sentence.
For this challenge, they actually expanded the system into a full 3-agent team. First, there's a planner, which takes the user's simple idea and fleshes it out into a detailed, ambitious product spec. Then you have the generator, which does the actual coding. And finally, the evaluator acts like a real QA engineer, actually clicking around and using the live application to find bugs.
So the big question is, does this whole complicated setup actually work better than just letting one single, powerful AI agent try to build the exact same thing?
Well, they put it to the test.
And the results, as you can see right here, are like night and day. The solo agent, yeah, it was fast and cheap, 20 minutes, $9. But what it produced was a completely broken, unusable game.
The full 3-agent team took way longer and cost a lot more. But, and this is the key, it actually delivered a working, playable game with extra AI features to boot.
And this really gets to the core of it. The Solo Agents app looked pretty good on the surface, but none of the actual buttons or features worked. The full team, on the other hand, guided by that ambitious plan and held accountable by the evaluator, produced a genuinely functional piece of software.
And check this out. The evaluator wasn't just saying, hey, this is broken. Look at the insane level of detail in these bug reports. It's not just flagging an error, it's pinpointing specific API routing issues and flawed logic in exact code handlers. This is the kind of super specific engineering-grade feedback that lets the generator actually debug and improve the app.
So what does all of this really mean for the future of building things with AI? It points to a really important shift in how we need to think about these systems. Now, you might think that as the base AI models themselves get smarter and more powerful, we won't need these complicated systems or harnesses around them. But this research suggests the exact opposite is true. Better models don't make the harness obsolete, they just raise the ceiling on what's possible. A smarter generator paired with a smarter evaluator can tackle even crazier, more ambitious projects that we can't even imagine today.
And this final thought from the researchers just sums it all up perfectly. The job isn't about waiting around for some magical, all-knowing AI to appear. The real, interesting work for AI engineers is designing these clever systems, these teams of agents that are constantly pushing the boundaries of what these models can achieve.
So that kind of leaves us with one last question. If you had an autonomous AI development team that could reliably build complex working apps from just a single sentence, what would you ask it to build? The possibilities are starting to look absolutely incredible.